we've spoken a little bit about rare species, but obviously scientists are still discovering new species on a fairly regular basis. So Prasanta, I wonder, how do you go about identifying and describing new species to science?
Sure. Well, a good first step is what Rosetta's doing, is sampling the environment for seeing what possibly is out there. And then if there's some sequences that don't match up with a known group, so, if you combine what Rosetta and Said are doing, so if you get the DNA from the environment with Rosetta, and then Said's putting it in a tree, a phylogenetic tree, a tree of life. And then you're saying, oh, okay, so these things, something here doesn't have a name that fits with what our genetic database says. That's a good first step. And that's usually the first step I take, because rarely do you walk up to a cave or a stream and say you found something and like, oh my God, this is definitely new. That has happened to me. And that's like euphoria, right? When you've there is no black cavefish. This is a black cavefish. Oh my goodness, this is a new species. That does happen when you're in the field, but you have to know what's out there first. And so putting it in a genetic tree is a great first pass. And then what you have to do is compare the actual individuals. So as Said said, you can use the DNA to re-identify what's in a museum collection. And it's often in museums where these specimens are housed. And then you go in and you measure and compare the morphological features. So features like I mentioned again about, different distances and meuristics, the counts, or genetic samples to show, there's this much sequence difference between the known species and what's potentially unknown. And then you fit it back in the tree of life with a name. So you give it a scientific name, a Latin name, a new genus and species, or just a new species name to see how it fits. And that's an old discipline. It's going on 200 plus years of naming species in the scientific way. But there are also local names that you try to incorporate and indigenous names that may exist. So you may also learn from the local people what species are there, and then you try to put it in a scientific context. So that's the sort of the brass tacks of naming new species.
Great, and it's really interesting that you mentioned working with local and indigenous knowledge there. Do you think there's a good connection between modern Western science and local and traditional knowledge of habitats and the biodiversity there?
I think it's a connection that's increasingly the importance is being understood. It's something that I've been lucky enough to have understood from my career, just going to these places and having boots on the ground. And, in Sri Lanka, the local fishermen had more names for the species than I did with the scientific context. And it actually made me think, oh, they're right. This one is skinny. They had a local name for skinny for one of the species. I'm like, oh, this is one of these that I didn't notice this had this feature. And we went back and did the molecular work and we did the comparisons in the labs. And I named it, it was actually a new genus. I named it Carla after the name that the locals gave it. So yeah, incorporating the local knowledge, they often, because they're there, understand, of course, their species better than we do. And in the past, Western scientists used to float in and do their own thing and not talk to the locals. And you're missing so much information by doing that. So yeah, working with locals and indigenous communities can really help our science. So yeah, I think that's a bridge that's being built still, but people are doing a better job at that.
Great, thank you. And we've spoken a lot about diversity, and I think many people, when you're considering biodiversity, think about the plant side of it and how important that is. So Sahid, you specialized in plants. Why did you choose to think about plant genetics and biodiversity rather than animals?
Wow, like one of those beautiful topics that say that would there be life without plants? And you also agree majorly the basic food that's available to human being are plants, and hardly will you see the vast majority are vegetarians and the people are dependent. Plants play a lot of roles in nature because when we look at the energy level, we look at the food level, we look at economy level, we look at even the recycling of nature itself, the balancing, the nutrient recycling, and even among those things that actually attracted me to plants is that plants is somehow simple to relate with, and it has a complexity that are interesting to study, like physiology, the morphology, and species are of variety. And one important thing that makes the genetics study of plants more unique is that you will be seeing physically that maybe they are of the same thing, but at genetic level you realize that there are a lot of differences in their mechanism, in their system, in their orientation, in their enzymatic reactions. These are beautiful things about what the plant is embedded in when it comes to biodiversity. And finally, I think plant has also been a kind of a species that are coding this very nature when it comes to the issue of relevance of the ecosystem sustainability, the climate change, and also a lot of things, survival, and even the health issues. So I think plants is very, very relevant here.
Yeah, fantastic. So perhaps almost more important than some of the animals for the ecosystem services they provide and being the base of the food chain and base of habitats for all life, really. So perhaps not as sexy as elephants or whales, exactly, but more perhaps environmentally important for us. So great to know that there's research going on into those. Fantastic. Thank you, Sahid.